Hello everyone, welcome back. Today we're going to look at question 3 of Paper 1 SPM at Maths 2017. So let's take a look at this paper. Alright. Diagram 3 shows vectors AB, AC, and AD drawn on a square grid with sides of 1 unit. Alright, so we can actually see here. Okay, so that's the vectors that are involved. Now, A. Find the modulus of negative BA. Alright. Okay, so you're trying to find the magnitude here. Now, so in this case, so negative BA is actually referring to this direction. Okay, let me use green. Okay, so it's this way, if you can see it. Okay, so it's that one. So instead, they're actually, when they put that modulus sign over there, what it means is that they're actually asking for the magnitude. Okay, they're asking for the magnitude of that line. So technically, they're asking for the length of that line in the number of units. So the way you want to do it is by using Pythagoras theorem. So you want to use Pythagoras theorem. So you actually use this length and this length. Okay, so those two lengths is actually, okay, one of them is 3 units and the other one is 4 units. So using 3 and 4, you can actually find the hypotenuse. So, okay, this particular thing over here is equal to the square root of 3 squared plus 4 squared, okay, which is the sides, okay, which is the two sides of the triangle. So you will get that the answer is equal to 5 units. Okay, so that is how you find the magnitude of the vector. Alright, how about B? Okay, given that given that AB is equal to vector B and AC is equal to vector C, expressed in terms of B and C, BC. Okay, so now you want to express this one in the form of vector B and vector C. Now, so the way you want to do it is you want to take a look over here. Now, so when they say from B to C, right, they're actually referring to, okay, let me choose a more brighter color. Okay, alright, okay, so they're actually referring to this part. Okay, so they're referring to that part. So B to C, so a good way you can get from B to C is from B to A and then to C. So it will be a combination of BA plus plus AC. Okay, a combination of BA and AC. Now, so BA is actually just the negative of AB, okay, which is the other way around, and then you plus your AC. So with these, you can actually find you can get your vector, which is negative vector B plus vector C. So here your answer is actually C, and it's minus. Okay, so vector C minus vector B. So that is your answer. Okay, so that's your answer over there, right over here. Alright, how about the second one? Okay, the second one I'm going to use a different space. Alright, so now you want to look for AD, right? You want to look for AD. Okay, so the way you want to look for AD is that, again, you have to look through the graph. So one way you can do is you can start with AB, 2, and BD, okay? The vector AB plus the vector BD. Now, AB we already have, okay, which is that answer, okay, vector B. Now, from B to D, however, we don't have a specific answer. But what you can notice is that, okay, now, what you can actually notice is that this length and this length is actually the same. So if you think about it, BD is actually twice the vector of BC. Okay, it's basically BC but 2 times itself. So I can rewrite this part as the vector AB plus twice of BC. And from here, we can actually get our answer already. Okay, so AB is vector B, okay, 2. Now BC we already found, which is C minus B. Okay, so vector C minus vector B. So here you have vector B plus 2, vector C minus 2, vector B. Then you'll get that your answer is 2 vector B, oh sorry, it should be negative. Okay, so instead, I'll put the positive one first. So 2 vector C minus vector B. So this is your answer. So the answer is 2C minus vector B. Thank you for watching.